One of the core reasons why we hunt for evil is to close the gap created by dwell time. Now, security tools generally fall into either protection tools, which aim to keep attackers out, and response tools, which we use along with our response processes after discovering an intrusion. But what about the gap in between the period after our defenses fail, but before our detection and response efforts kick in? Well, that's where threat hunting lives. If we can uncover signs that our protection mechanisms have failed, well, we can invoke our response processes and methods and tooling before the damage spreads. And starting on the network is one of the best ways to begin hunting for malicious activity. As Chris Brenton once put it, the network is the great equalizer. Because once you're looking at the network, everything almost becomes universal. Packets are packets, regardless of the underlying operating system or software or application. Right? Attackers can try to hide processes from /proc or the Windows API. They can migrate processes or inject into other processes, but so long as their tools need to communicate externally, that activity will leave traces on the wire. Now, we're not going to focus on network-wide threat hunting in this video because this series is focused on live endpoint analysis using PowerShell. Instead, we'll continue looking at the host level, but explore different utilities that we can use to interrogate network artifacts on a Windows system and correlate endpoint activity across running processes. And if you haven't checked out the previous video in the series where we hunt for malicious processes and command lines, you can find that video right here. And if you need a general PowerShell refresher before diving in, check out our PowerShell crash course as well. Now, previously, we left off with finding indicators of compromise and artifacts associated with a malicious PowerShell backdoor on a Windows workstation. And so we did that by focusing on live process enumeration and analysis, because as we looked at, oftentimes malware is going to need to execute as a process at some point during an intrusion. But there's much more that we can examine on a Windows system, especially network-related artifacts, to uncover additional indicators or suspicious activity worth investigating. The real power comes when we can correlate what's happening on the network with what's happening on the endpoint. Right? When we can pinpoint the exact program or application that's responsible for a certain piece of network telemetry, that gives us both context and more clarity during our investigations. And so let's go ahead and look at some ways that we can do just that. Now, there are many different commands and utilities out there that we can use to interrogate active network connections on a Windows endpoint. For example, a popular legacy choice is just the netstat.exe command. If I provide some arguments here, you can see we can very quickly enumerate all the network connections on this system. And so we'll return to netstat in a moment, but continuing on building up our PowerShell incident response toolkit, we can turn to the Get-NetTCPConnection commandlet. And as the name suggests, this is going to enumerate and return all of the current TCP connections associated with our system, along with, as we can see here, a number of different TCP connection properties, like the local or remote IP addresses or local or remote ports, things like the connection state, right? And also the owning process or the process ID that's associated with each of these connection events. And as we can see, we're not only just listing out the different services that are opening up ports on the system, but also any inbound or outbound TCP connections as well. Right, so in a malicious scenario, this output might include things like listening processes that are just idly waiting for an attacker's inbound connection, or also establish outbound connections over to an attacker's command and control server. Now, typically, in a standard Windows environment, we're going to see a lot of network activity occurring from any given system, right? We have to think about all the legitimate network traffic going to and from an endpoint during normal business operations. And so we'll commonly see things listed here as they relate to different Microsoft update services or different Microsoft telemetry collection, right? Or, different web browser activity like Edge or Chrome or Firefox or other various third-party applications that are running and reaching out to the internet in order to function. Now, as an aside, it's important that we understand the differences between the state of the connections that are listed here. And so we can see a number of different network objects that are set to listen under its state. Now, this refers to network objects that are listening for incoming connections on a specific port number. And we're going to see pretty common port numbers listed here for dealing with Windows systems. For example, we can make out 445 here for SMB, and also listening on port 135 for RPC traffic. Now, if we scroll down here, we'll see a few established sessions as well. And this is pretty self-explanatory, right? These are just referring to an established outbound connection. We can even make out the remote address that these connections are sort of bound to as well. Now, I don't see it in this list, but we might also see certain states that are set to time wait. And this represents a formally established outbound connection that's currently in the process of tearing down, right? And so if we happen to run Get-NetTCPConnection at the right time, we might see some previously established outbound connections that are currently in the process of tearing down. And so we'll see that set to time wait. Now, along with the state, we also have certain caveats to remember when it comes to how some of these remote and local IP addresses or interfaces are formatted, because it can be a little convoluted at first, but once we understand it, it makes a ton of sense. Now, when we run something like Get-NetTCPConnection or even tools like Netstat, because again, this is more of a general networking concept, we can see some listings here that have a local address of just 2 semicolons here, and we can see a bunch of these different listed here. To make this more clear, I'll just pull back the listening entries, and I can do that just by setting the state property here over to listen. And we'll take a closer look at filtering later on as well. But now we're just pulling back those different listening network objects. Now, at first, maybe you're thinking that, this specific local address here just means that we have an empty value, right? We just see 2 colons. Not quite. Essentially, when we see these 2 colons side by side here, this is just a short form or a short notation for referencing all of the IPv6 interfaces. And so what this is telling us is that these specific services are listening on all of the different IPv6 interfaces on our system. And as we continue down the list here, we're going to see a number of different objects that are set to 0.0.0.0. Now, this is the notation to specify all IPv4 interfaces, right? So all of these listings here mean that these services are listening on all of the IPv4 interfaces on the system. Now, I don't see it in this list, but if we see a reference to 127.0.0.1, that means that the listening service is only accessible from the local system, right? Meaning that no external machine on the network can connect to it. Now, if a service is bound to a specific IPv4 address, like we can see here, which is bound to 10.0.2.7, well, this is my current machine's IP address, right? So it means it only is accepting connections on that specific interface, which is important to note on systems that have multiple network interfaces. Right, and so for instance, the Get-NetIPAddress commandlet will show us the IP address configuration for a specific interface if we provide its IP address. And by doing that, we can see that this Ethernet interface is set up for my Windows 11 workstation. And so essentially, the address determines which interfaces on the system can access the listening service, and also whether it's reachable locally or externally. Now, unfortunately, a limitation with the Get-NetTCPConnection commandlet is that while yes, we can list out the process IDs that are associated with each connection, which is great for correlation, it doesn't give us the process name, however. But this isn't a huge deal, as the process ID is usually what we're after, but it does give us a bit of extra work to be able to tie that process to a name. For example, if I were to run the Netstat binary with a few useful parameters here, you can see I'm passing in the A argument here to show all the different connections and listening ports. The N argument here is going to skip hostname resolution and display numerical addresses and ports. The O flag here is going to show the owning process ID, right? So that process or that PID number, just like we're seeing here with Get-NetTCPConnection. And lastly, we have access to the B flag here to essentially show or print out the executable or binary or the file name that's attached to each connection. And so when I run this, and if I scroll up here past the different UDP connections here, we're going to get a similar output, just sort of formatted a little differently. Obviously, this is sort of a command line executable, so we're not going to get our results returned as PowerShell objects. That's one of the drawbacks here. But you can see here that we do get a nice listing of information, and when it can, it's going to list out the associated binary or process or the executable name that's responsible for each network connection or listening port. And so this can be very useful during an investigation, but Netstat does come with its own drawbacks, and we'll talk about more of that later, and it typically isn't as flexible and scalable as anything built into a PowerShell commandlet. But we can get a bit creative here, and we do have options for correlating network and process activity on a Windows endpoint very quickly using PowerShell. And so what I'm going to do here is set a variable to procs, and this is going to set up a quick lookup table of all the running processes on the system that are keyed by their individual process IDs. Right, so I'm just running get process here to list out all those different processes, and then I'm piping that over to group object by the ID property. And so this is going to group each process that we're listing out by its unique IP address. And then I'm adding on here as hash table to build out a hash table where each key is going to be the process ID and the value is going to be the group. And lastly, here we have as string to force the keys to be strings so that we can easily perform those string index lookups. And so now I can print out that procs variable. And when I do, we can see that it's a hash table where each key is going to be a process ID and each value is going to be the group object that contains the corresponding process. Perfect. So now we have this as our variable that we can invoke or introduce using different pipelines. And so what I can do specifically is use that hash table to quickly map each network connection on the running system to its owning process name. And really, you'd want to run this entire thing as a whole command, right? As a sort of one command line here, so that you can guarantee that the process IDs match up, because they can be volatile, right? And they can be reused and overwritten, but just for demonstration, I've split it up into multiple commands here. And so this command is going to join the results of Get-NetTCPConnection with our previously captured process info, so that our final table that we built here is going to show the local and remote addresses, the ports, the state, the process IDs, and importantly, the process name that's responsible for each connection. Excellent, there we go. We're getting a very similar output here, but we now have this additional process field. We can see all the different process names as they relate to the different connections. And so if we look at the established connections here, and we're sort of skipping ahead a bit, we can see a strange random process name here connecting to a remote endpoint, 10.0.2.6, over port 4444. As another example here, we can see the PowerShell process is making an established connection to that same IP address on port 443. We can also see a service host process here making an outbound connection over port 443 onto this 172.172.255.217 address. And if we were curious about this, we could look up this IP address, and when we do, we'll find out that it's affiliated and owned by Microsoft Azure. And so this is likely a legitimate Microsoft process making some sort of connection to Microsoft's backend to do some kind of activity, right? And if we really wanted to, we could dig into this more, but I'm going to be interested in these two processes here, and we'll get to that in a moment. By the way, if you do enjoy this kind of thing, we recently released the Security Operations 201 course on the TCM Academy, which dives much deeper into incident response and threat hunting and investigating intrusions at scale. We get much deeper into using PowerShell for incident response investigations, as well as powerful artifact collection methodologies. And so feel free to check it out. I think you'll really enjoy it. Now, we can also use a ton of built-in PowerShell filtering commands as well to turn this stack of network information into something more usable for us. And so, for example, if I run the get help commandlet here, and specifically look at the help page for the Get-NetTCPConnection, and if I start to type it out, I can just hit the tab there to autocomplete, and so that can be a quick little trick if you're trying to remember or spell a certain commandlet. And as we can see, we can filter based off of a number of built-in properties like the local address, or the local port, or the remote address and the remote port, the owning process, even things like the creation time as well, of course the state that we looked at, and much more. For example, if we wanted to list out only the listening ports or the connections that are currently waiting for incoming traffic, we can just run the state property here and set that over to listen. And now we're just pulling back all those listening connections. If we wanted to also narrow that down to a specific listening port, we can include the local port property as well, right? So I'll just set that over to 139, for example, commonly used for file sharing on Windows systems. And we're now listing out all the different interfaces that are listening on port 139. We can also focus on established connections as well, right? And as you'd expect, we can just set the state over to established. And extending this farther, we can even filter to a specific remote address. For example, again, I can see that our system is connected to another IP address in the same subnet on port 4444. Which is purposely a bit of a giveaway here, but this is the default port that a lot of malware likes to use, and so it can be one of those low-hanging fruit detections for us. And so what I'll do here is just append the remote address property and set that to 10.0.2.6. And so now we're just cutting down to the two connections that we have over to that other system in our network. And so we can get quite verbose in how we want to list out these different network objects. And importantly, we can correlate this network connection to its underlying process using that owning process property that we have listed here. And this refers to, again, the process ID of the underlying process that's making this network connection. And so I can take that PID number of 4908 and use it to filter for its process on the system using the getProcess commandlet. And if I wanted to get a bit more fidelity, I can run the same command again and pipe that over to select object to grab the name, ID, path, and description, and I'll format that as a list so it doesn't get cut off. Excellent. And so just like that, we can see that this process in question, this randomly named executable, is reaching out over the network to that remote IP address on port 4444. It's kind of a dead giveaway that this is a process that we might want to look into farther. Right, even more so, we can see that it's executing out of the temp directory for this local user, which is yet another anomaly that helps build our suspicion. And so now we've tied that network connection to its underlying process, specifically to the underlying process binary or the executable on the file system. Now we can take this a step farther. If you recall from our process examination video, we used the get-sim-instance commandlet to effectively interrogate additional information about processes like their parent process or command line arguments. Right, so I can run the exact same thing here, running get-sim-instance against the win32 process and filtering for the process ID that equals, in my case, 4908. Then I'm going to grab the name, process ID, command line value, and the parent process ID as well. Excellent, now we get a lot more fidelity and a lot more information that really makes me suspicious about what this process is doing. Right, if we take a look at the command line value here, we can see that this strange randomly named executable is running with a few different interesting parameters here, or arguments. We can see it likely is set to connect to that remote host at 10.0.2.6 on port 4444. It seems to be using some kind of base 64 encoded key parameter here. And it also includes some additional parameters like sleep. So this appears to be 5 minutes if this is referring to 300 seconds. We can also see jitter here is set to 75%. And these are very common kind of parameters that can be set and configured for different remote access Trojans or different command and control or C2 implants as well. And so by taking this process ID that we've identified and working our way up the execution tree, we can figure out what individual process spawned our suspicious executable. And so I'm going to run the exact same command again, this time just changing the process ID to the parent process ID of 11096. And just like that, we can see that it was executed through PowerShell. And so I definitely now want to hone in on this process and figure out when it was brought over to the system and from where. We can even go a little bit farther here and grab things like its file hash, right? So I'm just going to run the get file hash commandlet here, set the algorithm parameter over to MD5 to grab a quick MD5 hash. And when it comes to specifying the file that I want to grab the hash value for, I'm going to include a bit of parentheses trickery here to make sure that the get process commandlet runs first with the ID of 4908. And I'm specifically with the dot notation here grabbing the path value or the path parameter that returns from this object. And so really we can think of the parentheses here as just a way, similar to math, how we can make sure one thing executes first. And so what I'm really doing here is running get file hash to grab the MD5 hash for the specific path of this process ID, which as we look back to our commandlet here, returns to this specific path here. And so we could just type that in manually, just a quick way for us to sort of dynamically introduce that path there. And just like that, we're grabbing the MD5 hash, which we can, highlight and copy if we wanted to, and perform a quick lookup on whatever threat intelligence tool that we have available to us. And so for instance, on VirusTotal, I can search for that specific MD5 hash, and we can see very quickly that this is related to a malicious executable. We can even get some code insights here. We can figure out that, hey, this is a popular threat label for this specific binary. We can see different family labels that are associated with it. We can see it's very likely some kind of backdoor. We can see references to Meterpreter. Either way, this definitely is not a file that we want to have on any system in our network. Now we can even go the other way around, right? We can use a process ID that we've identified or discovered to correlate any network connections or listening ports that are associated with that process ID. And so what I'll do here is run Get-NetTCPConnection. I'll specifically look for any established connections here with the owning process or the process ID of 4908. And I'm just going to print out the local and remote addresses and ports, the state, the process ID, and also, interestingly, we get access to the creation time of that session. And I'll just format that as a list here. And so again, all this information we've already enumerated, but just to demonstrate, we can go the other direction as well, right? We can start out from a process or process ID and correlate that back over to network connections. And interestingly, if we take a look at the creation time here, this tells us when that connection was first established, which can be really useful for trying to determine how long something's been running, right? So as a bonus, we can calculate the session length by subtracting this creation time from the current date and time on our system, right? And we can do a clever one-liner like this, where we're just grabbing the get date, right? So we're running get date here in parentheses, and we're subtracting that from the results of this command. And when we run that, we get an output returned here, and we can start to make sense of how long this network connection's been established, right? We can see 2 hours and 48 minutes. If we wanted to, we could actually make this more human readable, but I assume you get the gist here. Excellent. Now, just for the sake of completion, let's go back to listing out all of the established network connections towards that 10.0.2.6 IP address. Because if you remember, we had that additional PowerShell process here that was connecting on port 443. Now, we can't see this from this output alone because we don't have access to the underlying binary as a property, but we do have the process ID of 8360. And so again, I'm just going to run get process here and provide the ID of 8360. And we can see that's related to PowerShell. All right, so it looks like we have this PowerShell process connecting to a remote IP on port 443. In fact, this is the same PowerShell encoded reverse shell implant that we looked at in the previous video. And so to prove that, we can grab its specific command line values as well, just like we did for the other process. All right, so just going to run get sim instance against the process class, filter for that process ID, and make sure that I grab the command line value as well. And just like that, we have our long string of malicious base64 text here. Excellent. Now lastly, another useful thing to mention here is that just like how we can enumerate UDP endpoints using Netstat, right? So if I were to run Netstat here and grab all the different connections and not resolve names, I'm just going to search for the keyword UDP here because by default, Netstat also includes the UDP connections. Well, we can do something very similar in PowerShell using the Get-NetUDPEndpoint commandlet. Right, so if I run this just on its own, we're going to get a pretty familiar output here, right? In this case, we're grabbing the local address and the local port for all those different UDP connections. And if we pipe this over to the get-member commandlet, we can see that we have access to a very similar set of capabilities and properties that we do with the Get-NetTCPConnection commandlet as well. Excellent. And that's all the time we have for today, but I hope you're starting to see the power of correlation in action. And just like with hunting for suspicious processes, there's no perfect list out there for indicators or anomalies to watch out for when we're trying to identify suspicious network connections. But once we understand what normal looks like in our environment, we can use visual cues and differential analysis to spot unusual behavior. We can also focus on how attackers try to blend in and how to untangle the true anomalies from the general background noise. A common giveaway is when we see network activity that just doesn't match what we'd expect for certain processes. Right? If we find that suddenly the notepad.exe or calc.exe is making network connections to a remote host, well, that's usually a clear sign that something isn't right here, right? Those processes don't normally make network connections or don't need to. There's no general business purpose there. We can also think about network session times as well, right? Remember when we enumerated the creation time of a particular established session, we can quickly figure out how long it's been active, right? Perhaps through doing this additional analysis, we can identify a long-running command and control beacon. Right? There are a ton of different strategies and indicators out there as well, but using commandlets like Get-NetTCPConnection really let us observe many of these behaviors and different properties. And once we start combining that information with other data sources, right, like correlating network information over to get process, or using get sim instance and performing IP and domain lookups, or grabbing file hash information and cross-referencing that with various threat intelligence feeds, right? All of this additional enrichment just gives us more of a complete picture and helps us spot suspicious activity with more confidence. And so thank you for watching, and feel free to leave a like if you want to see more of this content, and be sure to subscribe if you haven't already. Take care.